So today we are going to deal with the topic about complex number and quadratic equations. So let me give a brief intro about complex number. So we all know that root of plus 4 is plus or minus 2. Root of 25 is plus or minus 5. And root of 49 is plus or minus 7, right? So when it comes root of a negative number, that is minus 4, that arises a problem, right? So what about root of minus 25? We don't know the answer. And root of minus 49. So there arises a problem when it comes root of a negative number. We don't know the solution, right? Okay. So in order to get rid of this problem, scientists have done a lot of research regarding this and have found a new theory of complex number. So let me tell you briefly about that. So when I consider root of minus 4, I can rewrite it as root of minus 1 into root of 4. And I'm going to rewrite this root of minus 25 as root of minus 1 and root of 25. And root of minus 49 as root of minus 1 into root of 49. Okay. So we all know the value of root of 4, root of 25 and root of 49. That is plus or minus 2, plus or minus 5, plus or minus. But we don't know the value of root of minus 1. So here you can see that root of minus 1 is commonly present in these three terms, right? See here, here root of minus 1 is there, and here, and here. So scientists have found that the problem arises due to we don't know the value of root of minus 1. So they fix the root of minus 1 as I. That is nothing but the imaginary number. So this is the start of the complex number theory. So when they give a life for root of minus 1. So this is the basic intro part. See here, introduction. So in earlier classes, we have studied about linear equations in 1 and 2 variables and quadratic equations in 1 variable. So when we come to solve the equation x square plus 1 is equal to 0, we don't have the real number solution, real numbers of solution, because when we write x square plus 1 equal to 0, we can rewrite this equation as x square equal to minus 1, right? That is x is equal to square root of minus 1. Since we don't know the value of root of minus 1, we cannot say a particular real number solution for this equation, right? So scientists decided to fix this root of minus 1 as I. So when they intro that root of minus 1 as I, this equation also will have solution, but we don't have real solution for this. We'll have a complex number solution for this. Okay. So a complex number is nothing but the combination of a real number and an imaginary number. See here, a complex number is of the general form a plus ib, where a and b are real numbers and is defined to be a complex number. For example, they have given 2 plus I3, root of minus 1 plus I root 3, and 4 plus I into minus 1 by 1. These are all the examples of complex number. So my question is whether minus 2 is a complex number or not. Is minus 2 a complex number? Yes, of course, it is a complex number. Okay, you all may wonder about that because you will say that minus 2 is a real number only. Why it is a complex number? I'm saying we really want to know. So minus 2 can be rewritten as minus 2 plus I into 0. So I'm writing this minus 2 in the form of a plus ib, where a equal to 2 here and b is equal to 0 here. So these both are all real, these both are all real numbers. So it follows the definition of a complex number, right? See here, a complex number should be of the form a plus ib, and a and b should be a real number. So it follows now. So that's it. Minus 2 is also a complex number. So I can conclude that every real number is a complex number. But the converse is not. Converse means every complex number may not be a real number. Because if I take 2 plus I into 3, that is of the form a plus ib, it is a complex number. Is it a real number? No, because a real number should contain only real part. It should not have any imaginary part. So what does mean by real part and imaginary part? See here, for the complex number z is equal to a plus ib, a is called the real part, denoted by real part of z, and b is called the imaginary part, denoted by imaginary part of z. So a will be called the real part and b will be called the imaginary part. So for example, if I take 2 plus I3 is a complex number, here 2 is the real part and 3 is the imaginary part. Okay. So they have also given an example. See here, z is equal to 2 plus I5. Then real part of z is equal to 2 and imaginary part of z is equal to 5. And we can say, when we will say two complex numbers are equal. Okay. When we will say two complex numbers are equal. If I take two complex numbers as z is equal to z1 equal to a plus ib and z2 is equal to c plus id. Here, a should be equal to c and b should be equal to d. That is, here real part should be equal to the real part of the second complex number and the imaginary part of the first complex number should be equal to the imaginary part of the second complex number. So when I can say that, I can conclude that the given two complex numbers are equal. Okay, so this is just the basic intro of complex number theory. So I hope you all understand. So thank you for a wonderful session. Thank you.